B. Okay. Does anyone have any questions on 5A, B, or C? Because there may be things that we do in A, B, and C that we can use for D. Does anyone need C?
Do A, B, and C.
Okay, all of them?
Yes, please.
Okay, then we're going to do the whole shooting match. Okay, so once again, up here, they have defined H as the inverse of G. So I'm going to say this is going to be equal to the inverse of G times, or of -1. Now, this is important on the AP exam as well, that you somehow make that connection between what you're given and what you're going to use. Okay? Because when you look at the table doesn't have any H business there. It only has G and G prime of X. Does that make sense? So you have to make this connection on the AP exam if you are translating variables, H to G, that sort of thing. Does everyone understand that? Now, this is true only on the free response questions because that's the only time that you'd be checked on that. So what do we know? Well, we know that X of I is -1. Notice how I'm doing it right below the X, which means this is the value of Y at the point that we're interested in evaluating this interval. And if we go further and anticipate what we want to get, well, that's going to be 1 over G prime of X. So if this is Y, we have to find the X that is associated with the Y. Does everyone follow? And in fact, we go back to the function. When is Y equal to -1? Right there, because remember, we can think of this as X and Y. Whoopsie daisy. So when Y is -1, what is X? X is -5. Does everyone see what I'm doing there? And now it becomes pretty easy. What is G prime of -5? Well, we go to the table here, and when the original Y was 1, X was -5, the derivative of X is -3. Okay, does everyone see it? Okay. So now we're going to do H prime of -3. So again, this means we're actually computing the inverse of G at -3. I know it's going to be that relationship. It's going to be 1 over, and I'm going to color code this one a little bit differently, G prime of X, but it's not the same X as -3 because -3 is actually the original Y, and we have to find the X that is associated with the Y. Well, when Y is equal to -3, we go here to the table, and when Y is -3, then X is -4, and the derivative of G of X is -5. Now, again, when computing on the AP exam, this would not be acceptable. Okay? The reason it's not acceptable is you have to show some sort of substitution. So you have to show when you're evaluating this. And so you'd need to write also 1 over G prime of -4. Okay? So when you do that, look at what you've done. You've identified what Y is, and you've identified what X is. So see, you're showing exactly where you're evaluating, and then you make the substitution -5. Okay? And let's see if we have enough room to fit H prime of -5. Well, once again, G inverse prime of -5, that's going to be 1 over G prime of some X. What's the X? Well, the -5 here was Y, so we're going to have to use that Y to come back and find the X. So when we go to the table, and when we find Y is equal to -5, X is equal to -2, and G prime of X is -2. So that becomes 1 over G prime of -2, which is going to be equal to 1 over -2. Or -1/2. Okay? Okay, now the whole point about keeping up with the x's and the y's, it really comes into play on D. And let's look and talk about the x's and the y's. When they ask about the tangent to G inverse, and they say x is equal to -1, since they have referred specifically to the inverse in this problem, then whatever they say is x, that's the x of the inverse. Everyone see I'm adding a little I on the end as best I can? Here, I'll do it this way. So that's really important. If they were just referring to G of X and they said X was equal to 5 or something, well, they're talking about the actual X because they were not referring to an inverse. Does that make sense logically when you think about it? And once again, the only issue with doing these inverse problems is remembering what X you're dealing with. So if Xi is equal to -1, let's come over here. Let's do this in green. So we know the equation of the tangent is going to look like y equals mx plus b. We know that m is going to be the derivative of whatever y is. So that's going to be, so see what I'm doing? But now, why are we talking about? Well, we're talking about the inverse function. So I'm going to replace that with g -1 of x. Does everyone understand? That's the y. Times the derivative of y. Well, that's going to be g to the -1 prime of x. Does everyone understand that translation that I've made here? And once you get there, then it's just a matter of figuring out what's what. So the x that they gave us here was actually the inverse x. So this becomes g prime of negative 1 is equal to, now what's the derivative of g prime at negative 1? Well, remember, negative 1 is going to be the value of y, and we're going to need to find the value of x in order to reciprocate. So if we go back, whenever y is equal to negative 1, x is equal to negative 5, and g prime of x is equal to negative 3. So that gives us something to start substituting here. So the derivative here is going to be 1 over, let me try to respect the color coding, 1 over g prime of not negative 1, but negative 5 times x plus b. Is that following? So let's work to the right then. So now we need to substitute in values for, okay, hang on just a second. Let me step back for a sec. Guys, right here, for whatever reason, I put a prime on that next g rather than the inverse. Does everyone see that? That was a mistake. So let me make sure that I change that. Okay, that should be the inverse of. Does everyone understand? And so when we make these substitutions, what is the g prime of negative 1, or I'm sorry, g of negative 1? Well, remember, g of negative 1 is the same as x because the negative 1 is the same as the original y. So g inverse of negative 1 is the original x. So once again, we go back whenever y was equal to negative 1. What was x? It was negative 5. So that means the inverse has a value of negative 5. Does everyone get the idea? I didn't mean to do that. It's yeah, negative 5. I did mean to do that. So let's move out to the right and put it all together. So g inverse of negative 1 is going to be equal to negative 5. That's going to be equal to m. So 1 over g prime of negative 5. I've already forgotten. My memory can't even last 30. Negative 3. Negative 3 times x. Now remember, this is all the inverse, so that is the x of I, which is negative 1, plus b. So what do we get? And in fact, we could even put a little bi subscript there too, because they're b, the intercept of the tangent line to the function is going to be a different b than the tangent line to the inverse. And so we end up with bi is going to be equal to 3, negative 2. So finally, the equation is going to be, I'm going to change this, it's equal to b, that becomes negative 16/3. Assuming I didn't make some sort of a silly math mistake. Okay, that cleared up? I'm telling you, I mean, the more you do these, surely the more you're realizing, yeah, it's all about keeping up with the x's and the y's. Okay, how about next question?
Could you explain how L'Hopital's rule actually works?
The how or the what?
Like how?
To be honest with you, I do not know the derivation of L'Hopital's rule, so I can't demonstrate that off the top of my head.
Okay.
So my suggestion is go out somewhere and look for proof of L'Hopital's rule, and I'm sure that someone has it out there. Okay.
Okay. Then can you work like 3 then?
Sure.
From the textbook.
Sure. Okay. So the equation tangent line of the inverse function. So again, since this is making a specific reference to the inverse function, when they say x equals 3, they mean x from the perspective of the inverse function. Or in other words, let's do this one a little bit differently. It means that if we go to the original function, then y is 3 and x is the unknown. Does everyone see what I'm doing? Because that's like the xi here. So what's the equation of the tangent line? Well, every tangent line, y equals mx plus b. The slope is always going to be the derivative of whatever. I'm just going to say d dx of whatever times m plus b is equal to y. So that's always our first step. Let's figure out what is the slope of the tangent line. So since this function is the inverse function, then we're going to have the derivative of the inverse, f negative 1 x. Actually, I can get rid of that. Does everyone understand my notation there? Since it's the inverse. So now let's use the table to kind of fill in the blanks. So what is the derivative of the inverse? Well, f prime, the inverse prime at x equals 3. That's going to be the same as 1 over f prime of x. It's not the same x because the 3 is actually the original y. So if we go back to the table and find where is the original y equal to 3, it's going to be right there. So when the original y is equal to 3, x is going to be equal to 1, and the slope of f is going to be 2. So I'm going to rewrite this as 1 over f of 1, which is going to be equal to 1 over 2. And down in my line equation, I'm going to replace the derivative of the inverse as equal to 1/2. At that point, it's smooth sailing. We'll just have to substitute x and y to find b. But once again, when we substitute, we have to realize that since we're doing this with respect to the inverse, we have to use the y value from the perspective of the inverse, and we have to find the x value from the perspective of the inverse. Okay? And so when we do that, what did we decide? Well, the x value with respect to the inverse was 3, so that's going to be 1/2 times 3 plus b. And then what is the y? Well, the y is the same as what was the x, which is 1. And from that, we can compute b. What does that become? Minus 3/2, 2/2. That becomes negative 1/3. So b is equal to negative 1/3. If I didn't make any dumb mistakes, no, those are halves. How about 2/2 minus 3/2? So that's minus 1/2. Don't know where I came up with the 3. So the equation then is y is equal to 1/2 x minus 1/2. And remember, this is the x and y associated with the inverse. Okay? Does everyone understand that?